All right, so sometimes I sit around and I wonder, do these kids even know what a linear relation or function is? Well, today is your day because I'm going to teach you exactly what it is. All right, so a linear equation has no operations such as addition, subtraction, multiplication of a variable or a constant. So I know it doesn't mean a whole lot to you, but I'm still going to highlight it. I know you don't have this in your notes, so if you would rather write it somewhere else, you can. But the other thing that would really help you out, which seems it is common sense in a way, is that a linear function can be written or can be drawn as a line, which is up here. And the formula that you normally use, all linear functions can be written in this form: y is equal to mx plus b, which you should be familiar with that because you covered that quite a bit back when you were in algebra 1. Okay, so let's go ahead and go to the bottom. And just sometimes it may seem pretty simple, right? But when you're looking at some of these and I'm asking you, okay, is this a linear function? Well, none of these that I can see at least are written in the form y is equal to mx plus b. Sometimes for you it might be easy to tell, but if you can't tell, then the easiest thing you can do is you need to solve for y. And this is obviously assuming that you can solve for y effectively. For example, on number 1, is this a linear function? Maybe you can't tell. Well, what you should do is you should solve for y. So I'm going to add x to each side. So this is 6y is equal to x plus 7. And then if I divide the left side by 6, I'm going to do that to the right side. So if I divide this by 6, and essentially when you divide by 6, you're dividing every single term on the right side by 6. You would get y is equal to 1 over 6x plus 7 over 6. Now, you might be looking at this and you're like, well, that doesn't look like a linear function. But remember, this is just the y-intercept. It doesn't matter that it's a fraction. Like, this y-intercept doesn't matter. The point is that this is the y-intercept, this is the slope, so this is going to be a linear function. All right? Now let's talk about one that it's not. On number 2, if I'm trying to get y by itself, right? I'm trying to isolate for y. Well, to get the y out of the denominator here, I would have to multiply the right and the left by y. And when I do that, I would have 9xy is equal to 18. Now, here's the problem, right? The x and the y are multiplied together, and that's where you know. If you see anything like this, where the x and y have been multiplied together, then this is automatically not a linear function. Because no matter what I do, for example, if I keep solving for y, assuming you had that much skill in it, right? If I solve for y, I would divide both sides by 9x. Okay, so that's going to give me 2 over x right here. And there's nothing I can do. As soon as the x is in the denominator, I'm done. It can be done. I'm moving on. So this is no. Okay. On number 3, number 3 may look like it's not, but x over 11, remember the x is in the numerator, so we're good. If the x would have been in the denominator, I could have automatically said no. This is the y-intercept right there. And this turns out to be the slope. So notice that I'm writing that in a different way so you'll recognize it. Negative x over 11 is the same thing as negative 1 over 11 times x. Okay. So moving on to maybe a couple that you might not be familiar with. For example, on number 4, if we just look at that, even for me, like, I'm not really sure. But remember, if I see an x or a y for that matter on the denominator, almost, not all the time, but almost every time, it's not going to be a linear function. Okay, so for example, in this one, right, I'm going to try to get y by itself. So I'm going to add both this and that to the right side. So I'm going to have x over 6 plus 4. And now I'm going to divide by 2. And I know for y'all, like, oh my God, x over 6 divided by 2, what is that? Well, remember, you would keep change flip. So side note over here, x over 6 divided by 2 is the same thing as x over 6 times 1/2 if I keep change flip. So this is going to be x over 12. And remember that x over 12 could have been rewritten as 1/12 x plus 2, right? So this is a linear function, okay? Because it can be written in the y is equal to mx plus b form. Now let's look at some real quick that automatically know. For example, this y, that right there, let's see, yeah, this one's not going to be, because no matter what I do, the x and y are going to be multiplied. They're going to be intertwined somehow or another. This one definitely is, because it can be written in y equals mx plus b. This one, automatically, as soon as I see this right here, it's a no, because this is a cubic. You should know what that looks like. It's a cubic function. It's not a linear. If this is actually a rational, if you remember that from your unit 3 notes. So this is actually a rational. So I can say, no, this is a rational. All right, so some of them you can literally almost look at it and tell. Now on number 9, as soon as I see the x times y right there, well, I'm done. This is definitely not going to be a function, okay? Let's go ahead and go on to the back. The back is a little bit more involved. Now we're going to write equations in standard form, and there's a reason behind it, a little bit sort of logic. So you're used to seeing equations like y is equal to mx plus b like this, right? So what we're going to do here is to write it in standard form. You must get the x and the y on one side of the equal sign, and the constant on the other side. A needs to be positive, which is sort of a pain sometimes. A needs to be positive, right? Which notice that the A, which represents a number, needs to be positive. And then all of them needs to have a common factor of 1, meaning, let me show you an example. For example, in this one, when they added the 7y to this side, they ended up with this, right? Well, that almost meets all the criteria. X's and y's are on one side of the equal sign, the constants on the other. However, the only thing, x is positive, which is good. So the last thing they need to do here is that all of these are divisible by 7. So they divide everything by 7, and they get to that. They get to the lowest form, all right? And then we're going to show you why. This is sort of, if you have an equation like this, it's kind of nice if you're going to graph it, because it takes a lot less time. But anyway, let's go ahead and go on to some of these problems now. I'm not going to do all these problems because it do take sometimes a while. And I am going to take a separate piece of paper. You may want to do the same. If not, that's okay. Try to scrunch it up. I will do, let's see, I'm going to do 2. I'm going to do 4, 5, and 7. All right, so 4, 5, and 7 particularly, they're kind of tough. All right, so if you're looking at this and think, man, this is really tough. Well, that's because I picked the hardest ones. All right, the other ones are actually relatively easy. Remember, I want to get the x and y on one side of the equal sign. All right, so let's look at number 2. So I'm going to put number 2 right there so you can see it. So on number 2, we have 5y is equal to 2x plus 3. Now, this one's not really tough. I just picked it for you to see that it's really not that bad. I want to get the x and y on one side of the equal sign. All right, you can do it however you want to, but I'm going to choose to subtract 2x from each side. So I'm going to end up with negative 2x plus 5y is equal to 3. Now remember, the x value, the x number cannot be negative. So I need to multiply all of this times a negative 1 or just a negative. So all the signs are going to switch. Okay, and that is that for that. So this is literally written in the standard form that they want. So this is my answer. All right, now I'm going to go ahead and do number 4. All right, number 4. This one is one of the start getting a little tougher, not too much, but we have 18y is equal to 24x minus 9. All right, so they want us to write this in standard form. So the first thing I want to do is I'm going to get all the x's and the y's on one side of the equal sign. So I'm going to do it just like I did up here, right? I'm going to subtract the 24x, but they're not like terms. So all I can do is just rewrite it like this. So that's what I got. Now, at this point, let's do one thing, all right? I don't want the x to be negative, so yes, I can multiply by a negative. And that's going to give me 24x minus 18y is equal to positive 9. And then finally, last but not least, I need to look at all those three numbers, 24, negative 18, and 9. Is there a number that I can divide each one of those to get the lowest common factor, essentially. And if you look at it, hopefully you can kind of tell that 3 would be the greatest common factor of all of these, right? So if we just divide each one of these by 3, because remember, what I do to the left, I can do to the right, so I'm able to do that. I would get 8x minus 6 is equal to 3. So let's say that at this point you get there, you're like, well, I don't know if that was the biggest number that I can divide by. Well, look at it again. Is there any number that I can divide all of these 3, 8, negative 6, and 3, to make this, to reduce this, essentially? And the answer is no, I can't. So that's as low as I can go. This is the standard form. That's it. All right, let's go on to number 5. So 5, it's a little bit of a crazy problem here. And what's going to make it a little bit difficult is that you have 2 fractions that do not have the same denominator, or even a common denominator for that matter. So what we're going to do first is, again, same step. We're going to get the x's on one side. So I'm going to subtract 2/3 x from each side. I'm going to end up with this right here. Okay, so then at that point, what I want to do is I want to go ahead and get rid of that negative. So I want to follow the same steps, even though you can get rid of that negative at any time you want to, really. So this is going to be positive 2/3 minus 3/4 y is equal to negative 5. Okay, so now listen, I need to get rid of some of these fractions. Okay, so what I'm going to do here is, you can do this many different ways, but I think the easiest thing to do is just focus on this 3. I want to get rid of that 3. All right, so if I want to get rid of that 3, I'm going to multiply this by 3, and I'm also going to multiply this by 3. Okay, and then notice what's going to happen. That 3 and this 3 is going to cancel out. I'm going to end up with 2x. Great, I got rid of one of the fractions, but now 3 times negative 3/4 is going to give me 9/4. Now remember, when I multiply a number times a fraction, I'm only multiplying the numerators. Okay, if I can cancel this, I should, but it's not going to happen. This is negative 15. All right, so great, I got rid of one of the fractions. Now to get rid of the second fraction, I'm going to do the same thing, but I'm going to multiply, excuse me, I'm going to multiply this by 4 now. Okay, so that's going to give me 8x. Now that 4 and this 4, notice that I'm distributing, by the way, in case you couldn't tell. That 4 and this 4 are going to cancel out. Another way to look at it, if I multiply 4 times 9, that's negative 36. Negative 36 divided by 4 is negative 9. Okay, and this is negative 60. Right, now look at all these 3 numbers. Is there any number that you can divide all of these 3 to reduce them, essentially? And there's not. So that's it for that. And last but not least, let's see. I'm going to pick number 7 now. So number 7 looks like this. So we have 0.4 here. And this might be a little tougher for you. I don't want to have, so this is the thing that I haven't said, or I have said it, but I haven't said it enough times. The x's and the y's need to be whole numbers. They cannot be fractions or decimals. All right, so please make sure you do that. All right, so since they're not gonna, I don't want any decimals. I need to find a way to get rid of that. Now you can sort of, if you have some number sense, right? I know, for example, that if I multiply this by 10, that moves the decimal from here to here. And that might be one way to do it. The more difficult way to do it, which I don't think most kids think about, is that 0.4 is the same thing as 4/10. Right? I don't think you guys think about that, but again, I'm going to write it over here. So 0.4 is 4/10 is the same thing. But you should always just sort of keep that in mind. If you want to move the decimal, right? If I move the decimal to the right one time, then I have a 4x, and that makes it a whole number. So that's what I'm going to do here. I'm going to multiply here by 10. And whatever I do to the left, I'm going to do to the right. So I'm going to multiply this also by 10. All right, so I'm going to distribute now. So we have 4x, 0.4 times 10 is 4. 3y times 10 is 30y, and 10 times 10 is 100. All right, so that is going to do it for that. Let's see what else. What else is there? Okay, so we're done with this type of problem. So again, I picked some of the ones that are a little bit strange. All right, so most of the time, all you do is just subtract the x, and then make sure the x and y are positive, and make sure the x and the y, or the coefficients of x and y, and I'm talking about those two numbers, they have to be whole numbers. They cannot be fractions. All right, so let's go to the last couple of problems here. Now, in this one, I'm not going to solve number 10, but I'm going to tell you, for example, it wants to know the x and y intercept, and it turns out to be pretty useful because that's how you graph. That's how you can quickly graph something like this. So, for example, when I see something like this, I don't actually solve for y. I don't. I just plug in a 0 for x. So if I plug in a 0 for x, I'm just going to cover that up, and I'm going to solve that. And I can almost do that in my head, right? So if I plug in a 0 for x, that's going to give me 7y is equal to 14. If I solve that, that's going to give me y is equal to 2. Now that's my y-intercept. Notice, though, that to find my y-intercept, I had to plug in a 0 for x. That's why I put my finger over it, because 0 times 2 is 0. Okay, so that's that point. Now, if I want to find the other point, if I plug in a 0 for y and I just solve 2x is equal to 14, that's going to give me x is equal to 7, right? So x is equal to 7 would be right here. So again, notice that this is the x-intercept. So to find the x-intercept, I actually had to plug in a 0 for y, which may seem kind of backwards to you. So here's the nice thing. If you're graphing a linear function, all I need is 2 points, and I just need to draw a line through both of them. And there you go. There it is. All right, so I'm going to write this down so you remember. So to find the x-intercept, plug in y is equal to 0, or 0 for y, and solve. To find the y-intercept, you're going to plug in a 0 for x and then solve again. Okay, so essentially to find the x-intercept, you're going to, for example, the x-intercept here was 7, 0. So again, notice how I plugged in a 0, right, for y. And when I did, I got 7 just by following this equation. And on this one, to find the y-intercept, which in this case was 0, 2, same thing. I plugged in a 0 for x. All right, so let's do 1 here. Let's do number 11. Okay, so number 11, if I plug in a 0 to find, let's find my x-intercept. My x-intercept, I'm going to plug in a 0 for y. So I'm actually going to write this down so you see what's going on. I'm going to plug in a 0 for y, and I am going to solve for this, which is x is equal to -10. Right, and that's why you see me put my finger over this, because if I plug in a 0 here, I just end up with -x is equal to 10. Anyway, now to find my y-intercept, and by the way, that point, just to make sure we understand one another, would be -10, 0. All right, so if we pretend these are going up by 2, like 2, 4, 6, 8, I guess -8, -6, -4, -2, 10 will be all the way over here. -10, excuse me, will be all the way over there. Now for the y-intercept, I'm going to plug in a 0 for x. And that's where you saw me sort of put my pen over this number and then solve for y. All right, if I solve for y, I get y is equal to 2. So this number would be 0, 2. All right, so if I keep the scale the same, that would be 2 right there. All I need is 2 points to graph a line. There you go. Done. Okay, I don't need to solve for y. Now, last but not least, let's go ahead and do 12. Now, on 12, and by the way, this is a reason a lot of the times I ask you to write it in standard form, even though this is quite not standard form, because it's really fast. You just find your x and y intercept and draw a line through them. All right, number 12. On 2.5, let's see. Let's just do something here that might make our life a little bit easier, save us an extra step every time. I'm going to subtract 7.5 from both sides. So now I'm going to go off this equation just because it'll be a little bit faster. So to find my my x-intercept, I'm going to plug in a 0 for y. X-intercept. Yeah, I'm going to plug in a 0 for y. So I'm going to get 2.5 minus, remember, this is 0 now, but I'll write it for you. I'm going to plug in a 0 for y. It's equal to negative 7.5. And you just have to solve for this. So x is equal to negative 3 in this case. So my x-intercept is negative 3. My y-intercept would be, if I plug in a 0 for x, so I would have 2.5 times 0 minus 5y is equal to negative 7.5. All right, so that's basically gone. I don't need to worry about that. If I divide both sides by negative 5, let's see, that would give me 1.5 positive. All right, so my y-intercept is 1.5. All I need is 2 points to graph a line. All right, so this is normally why they want you to write it in standard form. So this is the lesson.